Everybody, do some science experiments today. Hope everyone's doing okay. Let's do some experiments. Let me get a little bit of a universal indicator going in this flask, and then we can do some acid-base experiments to start us off. Okay. Here we go. All right. Let's see what we look like here. Hey, how you doing there, you're local? Great to see you. Great to see you. All right, let's add a little bit of universal indicator here. You can see it's green. Yep, that's telling me my water from... I got this water from my tap. You can see it's a green color. Is that a little more? What do you think? How's that color looking? I think we need a bit more. That's okay, you're local. I've actually taken a little bit of a break. This is my first time back in a couple weeks. So I don't think you've missed much. I think we got a nice green color here. That's telling us that our pH is 7 in our fluid. Here, let me show you the universal indicator chart so you know where we are in terms of our pH, which is how acidic or basic something is. Yeah, right there in the middle, pH 7. pH 7, baby. All right, here, I'll put this down here. I'll put this little thing down here so you can kind of see what the different pH levels are. Come on, man. There we go. Okay, now we're going to let's add some acid first, okay? We're going to add a little bit of acid, hydrochloric acid, same acid that's found in your stomach. I'm going to add like 2 drops here. So you can see, you know, when I add the acid, it shifts to a red color. You can see that most of the acid stays in the center of the vortex. That's low pressure region. Yeah, nice pretty color change there, baby. Looking nice. Got to get my camera tidied up here a bit. What the heck is going on? Huh. I need to turn it the other way. That looks like about a pH, what, 4 or 5 maybe, I think? Yeah, it's like got a little orange color to it. I think so. Let's try switching it in the other direction. There we go. I got it nice and tight now. There we go. All right, let's add another drop of acid here. Like 2 drops. That should get it a nice cherry red all the way through. Sure does. All right, let's start adding the base now. We're going to drop the base here. Let's do 1 drop of base. In it goes. And watch what happens. Got a little flash of the rainbow there, didn't we? Sure did. Looking beautiful. Looking pretty, baby. Yeah, you can see as I'm adding the base, the pH is increasing. We're at like pH 7 now. I'm going to add a few more drops. Acid plus water. That's pretty much what I'm doing here. Twice baked potato, I think. Here, I'll do what you suggest here. So I've got some water here. All right. So here's some water. All right. There's our water here. Get it rolling. And then I can add some hydrochloric acid to it, just as suggested. So here we go. We'll add a little bit of hydrochloric acid. It shouldn't do anything. You can't really see the hydrochloric acid dissolving in the water real well. You drink that purple Gatorade, huh? I don't know if you'd want to do that. Let's get some universal indicator. You'll notice I've added 2 drops of acid here. So this is probably going to turn like a reddish color, which the pH indicator usually does in acid. Let's find out. So we're just going to, you can see it's green up here at the top. And sure enough, as I add it, look at that. Look at that. Isn't that cool? That's just beautiful. The way it just kind of stays centered in the vortex. It looks like our pH is just a bit below neutral, though, after everything gets dissolved in. Here's our pH scale. So you can see, indeed, that our color, it's a little tough to see. Let me just get the light on it a little better. You can see the color's like like a yellowish, so we're thinking about pH 6. A little more. There we go. It's looking nice. Looking nice. So Nabeem says they drink that purple Gatorade, huh? How about this? This looks like regular Gatorade here, huh? Like greenish yellow. Got a nice vortex going. Let's add a drop of acid. Here's a drop of acid. Boom. Look at the way that just... Come on, man. That's cool. Look at that red line. Just really pretty. Let's try that again. 1 drop of acid. What a beautiful contrast in colors. Looks nice. Try another drop. Oh, better do another. Interesting. It's like it's not persisting as long this time. Wonder why that is. All right, let's. What happens to drink if you drank that yellow juice? It wouldn't go well for you. One of the dyes that's in there used to be the active ingredient in X-Lax. So you know, you can drop the emoji in the chat as to what you think would happen if you drank some of that. There's a drop of base. You can see that blue color. Come on, man. This vase works really well. The colors that you get in the vase look really pretty. Is that another drop of base? There we go. Yeah, we're getting really nice flow patterns. So that pH now, it's at least 10. So when you see that purple color, you got your pH up there really high. Yeah? I hear you, Twice Baked. So when do we break the vase? Well, I don't know. I'd probably have to add quite a bit of acid or base to do that. That's a gorgeous purple color, man. Gorgeous purple. Let's start adding some acid. We'll add some hydrochloric acid, see what happens. Here we go. Couple drops. 1, 2, 3, 4, 5. Let's see what happens with those 5 drops. So you can see that violet color becoming more red as the acid goes through. You know, when you add acid, the pH is going to drop. Let's add a few more drops here. Get her going. Come on, baby. Come on, baby. Let's see what happens. Bunch of drops of acid. I think we need more color. But that is pretty. Oh, is that pretty? I'm gonna add just a bit more color. All right. So here I've got another shot of the universal indicator. Look at that, man. Come on, man. Ha, that's beautiful. Look at that deep red line. So that tells me that the center of the vortex, there's a lot of acid in there. Yeah, that was beautiful. Very pretty. All right, let's chase it with a drop of a little bit of base. Oh, that's a gorgeous flow pattern. Come on now. Oh, that's cool. That's really cool. So what we're doing here, we've got an acid-base indicator. It's a universal indicator. It's also known as rainbow indicator. It changes color depending upon pH. pH is just how acidic or basic something is. So these are different colors that you're going to see at different pH values. So right now, you know, it's mostly like a yellow-green, and so it's like a pH 6 or so. Let's add another drop of base there. A couple drops. Get those nice flow patterns going again. Oh, yeah. Oh, that's beautiful. Let's add some acid. That'll give us a red color, right? The acid drops the pH, makes our indicator go red. You can see that swirling through. Get a lot of interesting color mixtures. How's everybody doing today? Anybody going to be watching the Super Bowl later? I'm planning on it. I guess I can make some, oh, thanks there, Mark. Oh, I love it. Yeah, let's. I'm going to make a few colors in honor of the 2 teams in the Super Bowl today. Let's see if we can do that, man. So let's see. We're going to get. We got to get blue and red. That'll be for the Patriots. So let me add just a little bit of acid to this side. See, we want to get this side blue. We're at pH 10. I got to add some base to get us down to like a pH 9 or 8. Excuse me, acid. So I'm adding acid to this, which should lower the pH. And then we got to get this side over here red. I'm going to have to add a bunch of acid. So I'm just going to squirt a bunch in there. So I think oh, that was gorgeous. Look at that red fire. I think it's a little orange. So there's your red color. All right. blue is tough to get. If you drank that purple stuff or the red stuff, you'd probably end up, if I drank it, the live would end in a couple minutes because one of the dyes is a laxative. Yeah, I just can't seem to get that blue color. Come on, man. Let me get this going a little quicker. A little bit more blue. Come on now. It's like purple and red. There, I got it. There we go. We got the blue and the red going on, yeah? We got the blue and red going on. That's in honor of the Patriots. Now we're going to add a little bit of base to this side because we got to get green and blue. I think those are the colors of the Seahawks, yeah? Here we go. A little bit of base over here to raise the pH. There's one drop of base. Let's kind of watch what happens. Oh, nice. Someone from Massachusetts. Nice to hear. I think that's what you're saying, Mass, there. You got it, Edie. Hey, we got a little rainbow there on the left. There we go, folks. There's your green and your blue for all you Seahawks fans, if anyone's a Seahawks fan. Looks like it turned back to yellow. Let's add just another little drop, just a little tiny drop of base. See if we can't get to that green and their blue. There it is. That's for you Seahawks fans. But I want to focus in on this flash because I think it's really gorgeous. Cape Cod, very nice. I've got some family in Rhode Island. I know that's not exactly the same spot, but good to hear it there, D2. Good to hear it. Add a little more acid. Yeah. Get some color changes going on here. Close enough, thanks. You're too kind. Some Midwestern out here acting like he knows what's going on over there in New England. Not at all the case. All right, let's see here, man. I'm adding acid. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that the stuff that I add is a lot more concentrated. What happens to FT? 20 calcium. I don't know what you're asking. I apologize. What happens to FT? I think you might be asking what happens to it. Not sure what you mean by it. I apologize. I really am trying to understand here, but I'm just not getting it. Hey, got a little rainbow flash there. Come on now. God, I love that. That is so pretty. When you get all the colors, look at that. So gorgeous. So gorgeous. I'm loving it. I'm loving it. A little acid here. I got another experiment ready if folks want to see that too. We can do some salting out experiments. Right now I'm just enjoying the beauty of acid-base reactions with universal indicator. When I add acid like I'm doing now, the pH drops and that shifts you to yellow, orange, or red colors. Well, that's the beauty of the internet. We are far ejected. It comes to the miles, but still close by coming online. Come on, man. Love it there, D2. Come on, D2's winning the comments so far. D2 is winning the comments for sure. I love it. It's beautifully said. Continuing to add acid here, and as I do that, the pH drops, shifting us to more red colors. And then once we get a nice red color, I'm going to go ahead and add some base, sodium hydroxide base. Here we go. A couple drops. Let's just do one, see what happens there. That should shift us to more blue colors once it finds its way through the solution. Better add another drop. Looks like the acid's consuming most of the base. One more. One more. I'm trying to capture the rainbow, man. Gotta capture the rainbow. There it is, folks. Oh, I don't think I quite got it. Give me one more drop there. Come on. Come on, Tommy. Let's see it. There it is. Ah, a little too much. What happens if you drank that stuff? Yeah, it wouldn't end well for you. There's the indicator dyes are not especially good for you. Here, let me show you here. Here's the indicator that I add. You can see the cautions on the label. This is just flammable. Causes skin irritation, causes serious eye irritation, toxic if inhaled, may cause drowsy or dizziness, may cause damage to organs. So yeah, I won't be drinking it anytime soon. Taste the rainbow bonsai. Yeah, that's a rainbow I won't be tasting, my friend. Yep, we're looking up the warning icons. Yep, we're not drinking that. Oh, that's gorgeous. Gorgeous colors. All right, let's try this. After I want to just try to capture that rainbow one more time, and then we'll try something else. A little bit too much base. But you can see it in there. You see flashes of all the colors. Mostly violet, though. Let's try this, man. Here we go. Let's do a different experiment. Here we go now. Okay. Here's what I'm going to do. We are going to take some water. All right, there's some water. And let's see, to this water, I am going to add some isopropyl alcohol. See if I got my funnel here so I can make sure I do this correctly. Yep, here we go. Let's add some isopropyl alcohol to the top. You can see that it doesn't mix perfectly. I don't know if you can tell that. I mean, there's some mixing going on, but it's not perfect. Like, you can sort of see two layers if you look very carefully. There's two different layers. Yeah, D2, I'm a chemistry professor. What happens to shake on the left side? We're going to shake it at some point, but if you look here, right, you can kind of see this has got two layers. I mean, there's a bunch of bubbles in here. So once those bubbles dissipate, you may be able to see that this is like a two-layer fluid, okay? So what I'll do is I'll add a little bit of violet food dye. Thank you there, D2. We're going to add some violet food dye. Watch what happens. Oh, look at that. That is gorgeous. Look at that. Look at those flow patterns, man. What the heck? What the heck is actually going on? Let's add another drop. Looks like tendrils. All right, so there's 2 drops. 2 drops coming down. It is pretty. Definitely is pretty. Thank you there, D2. All right, let's back this out. So let's recap what we've got here. We have, I agree, I think it's very beautiful. You can see, though, it kind of stops, right? I think the dye, it goes through the alcohol layer, and then it kind of stops. Like down here, it's very water-rich. Thank you, AC. Appreciate that. I see you. Appreciate the comments. I'm going to go ahead and shake this up. And if that, if that purple dye spreads through the whole mixture, and we don't see 2 layers, then we know that the alcohol and the water mixed. So let's do that, all right? I'm going to shake this up. Let's see what happens. All right, put that there. And indeed, it looks like, hey, very cool, welcome. So AC, what we have in here is water and isopropyl alcohol. All right, this is a 500 milliliter bottle. I added 240 milliliters of water, and then I almost filled the bottle with isopropyl. It's 91% isopropyl, by the way. That's important. I mean, if you're going to try to repeat this, that's important. So look at all those bubbles, man. I'm going to add another drop of the violet food dye. So all I have in here right now is water, 91% isopropyl alcohol, and food dye. You're welcome. We're going to shake this up, and then we're going to add something else to this. Let's see what happens. So here we go. Let me just mix this up. So you can see the water, the dye, and the alcohol, they all make one single phase. We say that the mixture is homogeneous. It's the same all the way through. Now what I'm going to do, though, I'm going to add some salt to this. We're going to watch what happens, all right? You guys are going to love this. You're going to love this. This is one of the coolest experiments, man. All right, here we go. In goes the salt. It's going to take a little bit to get it all in there. So in goes the salt. I'm adding salt to a mixture of alcohol and water and some violet food dye, and then we're going to shake this thing up. It takes a little bit. We got to get the salt to dissolve. It's going to take quite a bit, but let's take our time. We got to shake this up. And so the salt is dissolving into the fluid. And then we're going to watch what happens. So again, what I have is a mixture of alcohol, water, purple food dye, and I've added salt to that. All right, let's see what happens, baby. Come on now. Let's see what happens. I think that might be enough. Let's see. I'll know pretty soon if I have to shake it more. Is it working? Yeah, I think it's working, baby. I think it's working. Can you see it? So what you might notice down there at the bottom, you see like a blue layer. Up at the top, it's magenta, and in the middle, it's violet. It's separating right now into 3 layers. The top layer is an alcohol layer. The bottom layer is salt water, and the middle is a mixture of salt water and alcohol. It's not quite enough salt dissolved, so we're going to try it one more time. Let me just shake it up just a little bit more. We just got to get just enough salt so this will separate nicely. See if it does it. So what happens is the salt and the water, they're strongly attracted to one another. And the attraction is so strong, it's just like when 2 people fall in love and they date exclusively. It's kind of like the salt and the water are dating exclusively. The attraction is so strong that they push the alcohol out. So that's what you're seeing. You're seeing an alcohol layer up here. You're seeing a salt water layer down here that's more blue. And then in the middle, you see what we call an emulsion. The emulsion is a mixture of the alcohol and the salt water, and that it's a transient mixture. It's going to separate over time. Thanks there, 94. Let me. I'm going to try to get the camera at just a little bit better angle so you can see what I'm talking about. Yeah, there you go. Now you can see it much better. All right, you can see the 3 layers separating quite nicely. The blue layer on the bottom, the alcohol layer on top, and the emulsion in the middle. What's nice is the violet, thanks there, D2. The violet dye, it's actually, you can see it's made of 2 different dyes. There's like a bluish colored dye that goes in the salt water, and then there's a magenta dye that ends up in the alcohol layer. Boy, that emulsion is really lasting a long time, like a really long time. Probably because I didn't get the best mixture of salt and water. I think if I add just a little bit more alcohol, we're going to try that just a bit. I just gotta change the phase just a bit. We'll get a much sharper separation is my guess. Let's give it a shot. I might also try adding more salt. Just a bit more salt. Sometimes that helps. A little bit more salt. Give it a shot. Then we'll try with the universal indicator. That's even cooler. All right, that's probably enough. All right, let's see if this works a little better. See if we can get a nice separation here. Mix that up. Get it salty, baby. Get her salty. All right, let's see if that separates a little better. Maybe, maybe not. Maybe today's not my day, huh? Yeah. I think we're doing okay. Yeah, it's separating out. We can see the blue on the bottom, magenta on top, the emulsion in the middle. Let's set up a separate one, as that one is separating. Let's set up another one, okay? So to this other flask, I'm going to set it up just like this one. Let's add some universal indicator to it, though. So universal indicator, this is that stuff that changes color. Here, I'll add a little base to this. You know, it's universal indicator in this vase on the right. So you can see when I add base to it, it changes to a violet color, and I'm going to start adding acid to it. And when I add acid to the flask, it shifts to a more red color. And it can show all the colors of the rainbow depending upon the pH. What's making the vortex, if you look down in there, see that little thing that's been here, I'll turn it off. It's a little magnetic stir bar, and it's resting on a magnetic stir plate. So then when I turn it on, it causes a little, there's a little magnet that stirs in the stir plate, that spins in the stir plate, and of course that makes a little magnet stir, and that allows the stir plate to spin. Leaves my hands free to do experiments. Yeah, it's like we're doing a titration. Thanks there, J94. All right. Yeah, we can add a few more. Let's add a little acid over here. Get it nice and red. We'll see if we can get the rainbow before we set up another bottle. A little bit of acid. Yep, I'm using universal indicator AC. You must be a chemist, chemistry teacher, or chemistry student. All right, let's start adding drops of base. Here's the first drop of base. Boom, in it goes. That's pretty. Come on now, that's pretty. The equivalence point, Pam, would be when it turns green. All right, let's add another drop of base, because that's going to be pH 7, and I'm just using sodium hydroxide and hydrochloric acid. Thanks there, Super. Look at that. Come on, we got a little rainbow action. I love it when that happens. This may get us to green. Didn't take much. Let's add one more drop. Look at those flow patterns, y'all. Gosh, I agree, 4037. We've got some really interesting flow patterns. The shape of the vase makes the flow patterns really interesting. Universal indicator AC is just a mixture of dyes that change color depending upon the pH of the solution that it's in. Thanks there, Gabrielle. So the universal indicator I'm using it shows these colors at these different pH values. I'll set it over here, and if folks want me to point to it, I will. Otherwise, I'm going to focus on just the beauty of the science. Add another drop of the base. Yeah, we're well past the end point at this point. You can see that's nice purple color, so, that's pH 10. Very high pH right now. I'll add one more drop to get us nice and basic, because it's kind of blue to my eye, but on the camera it looks violet. But I'll add one more drop, make sure everything looks good and violet. And then we're going to start adding some acid. The acid I'm adding is hydrochloric acid. So J94. Wish they'd have had classes that taught more stuff like this. Yeah, I mean, it's all a bunch of useless knowledge, huh? All right, I'm starting to add drops of acid. I'm not saying the vocational school is useless. I'm saying what I'm doing here is useless knowledge. It's just fun, though. It's beautiful, And I guess beauty is, yep, Pam, HCl. Beauty's not useless, in my opinion. Here we go. Let's keep adding drops. I'm adding drops of acid. Couple more drops. Come on, baby. Come on, let's see some color changes. Yeah, drop the emoji heart of your choice, the color emoji heart of your choice that you'd like to see, the color you'd like to see, and I'll try to make that. Anybody gives me out there? I agree, AC. Come on, the first emoji heart I see, that's the color I'm going for. Who's going to drop it? Who's going to drop the color in the chart, or excuse me, in the chat? I'm adding acid right now, trying to get the pH down. Breen. What color is Breen there, the planet? Taste the rainbow. Yeah, right now I'm adding acid, Pam. Right now I'm adding acid. I don't know what color Breen is. I think it's half brown and half green is my guess, the planet. Right now, I just keep adding acid. That's making the pH go down, right? We're heading down to like pH 4, 5, maybe pH 3 once I get it nice and red. Oh, wow, J94. Yeah, I agree with you, Frog. Science is not about proving stuff. Yep, it's about trying to find what's wrong with what we know. Yep. And I'd say constructing the best explanation that we can, given our knowledge. I'm trying to find out where that's wrong. All right, we've got a nice red-colored solution. Let's add some drops of base. 2 drops. Let's see if that gives us the rainbow we want. I agree there, Ayantika. There's no colored heart options. What the heck? I'm using 20% by weight sodium hydroxide and about 10% by weight hydrochloric acid. There it is. There's a green. Drext Eagle. And AC1 wants to do purple and blue. So we're going to go green first. Green's tough to get. You gave me a challenge there, Eagle. I see some red here. Okay. It's okay. We got to try to get green. Green is tough, man. I'm just there. I see. There's some flashes of green, but to get the whole vase green, it's not easy. So the purple and blue. How about this right there for you? There you go. Asking ye shall receive. There you go. Frogs wants the whole rainbow, baby. And look at that. We got your green. We got your green. Isn't that nice? Oh, it fades to yellow, though. So let's add just one more little drop of base. See if you can't keep that green color to persist. Frogsy wants the whole rainbow. It's like an aqua, but if we wait, that should shift to green. This is for you, Eagle. There's your green, baby. Come on, baby. All right, now we're going to go for I saw a blue and a violet, which I have over here in this bottle, right? But let's get it in this flask over here. And let's put a second flask up. Let's put a second flask with the universal indicator in it up over here. We'll get both of them going. See if we can't get the blue and the green. Blue's tough to get. Blue is not easy to get, but we're going to try it. All right, there we go. Now we can see both containers. I'm going to add a couple drops of sodium hydroxide over here on the left. Man, that went straight to violet. Holy cow. All right, let's see what we got over here on the right. See if we can get that to blue. There you go. There's your blue and your violet. This is not a red cabbage indicator, frogs. This is, I don't have any Viva La France. I'll tell you what, though. I do have videos where I put sodium metal in some water. Thank you there, Frogsy. And so you look through my, you look through my YouTube shorts, and you can easily find some of those. I got like two or three of them where I do different things with sodium metal and water. All right, I also saw a request for red, so I'm going to try to do that now over here on this side. So I'm going to start adding acid now. I'm adding acid to the flask on the left. That's going to lower the pH. While everything equilibrates, you may see a whole bunch of different colors. It's like, we got the rainbow, baby. Come on now. You see that? We got a little flash of the rainbow, which I always love. I like dissolving copper in acid. Gives you a green liquid. Come on, B-Ran, you tell me about it. And then adding an iron bar and watching the copper crystals grow. Indeed. Thank you there, Viva La France. That rainbow cloud effect. We got it, man. We got it. Glad you found him, AC. Thank you there, Michael Moore. Appreciate that. Yeah, we got like the, looks like the Patriots colors, huh? We got a Super Bowl going on today for those that follow football. We got the blue and the red. All right, let's do I want to do another of these I want to do another one of these color bottle experiments, okay? You guys will like this. Let's try it here. Let's give it a shot. So I got some water here. All right. Bunch of water. And do I have enough? Oh, I don't know if I got enough. We're going to find out. To this water, I'm going to add some isopropyl alcohol. There we go. And it goes. In goes the isopropyl alcohol. Oh, man. Is that enough? I don't know if that's enough alcohol. Do I have any more? Well, we'll have to see. We'll have to see if this works. Okay, so I got my water. I got my alcohol. We're going to add some universal indicator there. How you doing there, Marcin? Sorry. All right, I'm going to add some universal indicator now. Let's go like, I don't know, 2-3 squirts. Yeah. So it looks like that universal indicator is staying in the top layer. That's probably where the alcohol is. I'm going to give it one more squirt. So it's like there's 2 layers, right? There's an alcohol layer on top. There's a water layer on bottom. What I'm going to do is I'm going to mix this up. And if we see that, that there's just one single layer, then we know that the alcohol and the water, they mix. By the way, the indicator that's in here is the same as the indicator that's in here. It's just that they're at different pH values. So let me shake this up. There we go. All right. So we got a single fluid, right? A single fluid, the water and the alcohol mix very well. I do have one, Frog Z. I've definitely got one. Yep. I need to do some experiments with that for sure. Now, you see, it's like really cloudy in there. That's because there's a bunch of bubbles. So when those bubbles dissipate, that's cool there, Frogs. I love it. I need to do more experiments with it. Anyway, now what we're going to do, remember, this bottle has water and alcohol in it, and then a little bit of coloring. It's got some, universal indicator to it. And now I'm going to add to this, we're going to add some salt. We're going to see what happens. Let's turn this off. Turn this off so we quit the humming noise. Okay, now let's add some salt, baby. Those were pretty bubbles there, PSI. Here we go. Let's add some salt and see what happens. Get on in there. Get on in there. What's going to happen? I don't know. We're going to find out. That's what we're doing. I hope I got the ratio right. I'm not sure I do. Forgive me if this doesn't work. All right, let's put the lid on. Looks like something's going on. Like, if you notice, it looks kind of more yellow on the bottom and more green on top. What's going on with that, huh? I don't know. Let's shake it up and see. Okay, so now what we have is a mixture of salt, water, and isopropyl alcohol. That is annoying. Frog Z, here we go. Come on, shake that baby up. Shake, shake, shake. Get that salt dissolved in there, and let's see what happens. What's going to happen? I don't know. I might have to add a little bit of some of the alcohol from the other bottle to get this to work. We'll see. Let's see what's going on. Is it going to work? Oh, it's totally working. Totally working. Can you see it? So what's going on, if you see down here at the bottom, you see a faintly yellow layer. Up at the top, it's more dark yellow. So this is separating into a saltwater layer and an alcohol layer. There's also a middle layer that's a mixture of salt water and alcohol. That's transient. That won't last forever. So there we go. You can see that we have, by adding the salt, I've separated the water from the alcohol. And the reason why this happens is the water and the salt. When the salt dissolves in the water, there's such a strong attraction. The attraction between the salt and the water is so strong. It's like 2 people that love each other very much and then they date exclusively. So because the salt and the water like each other so much, they basically push the alcohol out. We can also see that the dye that I added, it's much more soluble in the alcohol than it is in the salt water. It does look like a chemical sunset. Now, what's fun about this, we can start adding. Remember, there's universal indicator in here. That's this stuff, right? Here, let me show you. So the universal indicator, that changes color. I'm going to add some acid to this. So I've added acid to this. That's in this bottle too. And the acid that I added makes this change color, right? And it changes color depending upon pH. Right now in this bottle, the pH is about 6, maybe 4 or 5 or 6, somewhere in that neighborhood. So if we want to make this, let's say, more acidic, I can add some acid to it. So let's check it out and watch what happens. I'm going to add some acid to the bottle over here on the left. In it goes. And you see that red color? You see that red color developing? Well, that's because the acid has, very low pH. pH 3. You can tell that the acid is more dense than the alcohol because it's sunk below it, but it's less dense. Look at that. It's less dense than the salt water, so it floats it floats in between the two layers. A noise is bugging you. Sorry there. Thanks for reminding me, Viva la France. Appreciate that. Okay, now I'm going to shake this up and make the acid. We're going to, mix it through the whole solution. It does look like a sunset ACV. Mix that up. Now we've got a lower pH. I'm going to say like a pH of 4. Oh, look at that gorgeous separation. Look at that up there at the top. Very pretty. Yeah. Same kind of separation going on. We got the saltwater layer on the bottom. We got the alcohol layer on top. And then this middle, like this is like a reddish orange. In the middle, we have an orange. That's an emulsion. That's a mixture of the alcohol and the saltwater. And that's gonna shrink over time as the two layers separate. What I added to make it red was hydrochloric acid. You got it there, Frogsy. Now to this, we're going to start adding some base. Let me add a little bit of base to this. See what the color change is that we get if I add a little bit of base. All right. Add a few drops. 1, 2. Come on. 2, 3, 4. That should be enough. That should be enough. It's a little hard to see the base, but if you look closely, you can see some wisps of it in the dark orange layer. Let's shake this up and you can watch what happens here. Yes, I agree. It looks a little pink. It does look pink. Here we go. So let's shake this up. I've added some base to the mixture. Let's see what happens. We mix that up. What's the color going to go to? It looks like it's blue. Is that where we're going to settle? Are we going to settle at a kind of an aqua color? Thanks there, Sai. Let's see. What the heck? Look at that there on the bottom. Where's that color coming from? What the heck, man? I'm kidding. I know what's going on. But it does look goofy. Right now, we got 2 different colors. We got 2 different colors in there. What the heck is going on? How in the world does that happen? How did we end up with 2 colors in there? Well, it's a bit complicated, but basically, there's 4 different dyes in Universal Indicator. That's right, Viva la France, come on! Viva la France. The chemist has entered the chat. So what's happened is there's more than one dye in Universal Indicator. One of them is phenolphthalein. And phenolphthalein goes in the water layer, and it's usually colorless. However, at a high enough pH, it becomes this color, and you can see it. Not cool? Let's add some acid to this. So you got to remember, there's like multiple dyes in Universal Indicator to get the rainbow effect. All right, let's add some acid to this. See what happens. Here we go. This is pretty. Add drops of acid. 3 drops. It looks like the sun breaking through the night. It's like sunrise. You see it? See how that acid goes down to, it sinks below the alcohol layer, but it's not dense enough to sink into the saltwater layer, and so it just kind of builds up right here at the interface. And because it's acidic, it changes the pH to very low, which changes the color to red. Isn't that cool? I agree. It's really pretty. Let's add a little more. I want a little more sunrise going on here. I agree, ACV. I think it's very gorgeous. We're going to add a few more drops. There we go. It's like a storm cloud that's lifting. And we got a little more sun than we did before, yeah? Stable. So Psi, it's not stable in the sense that just watch, I'll mix it. We'll show you. I'll mix this up. This 3-layer mixture is not stable, but here we go. This will be. So once I mix this up and this does its separation, that's going to be a stable mixture. It's going to take a little bit, though. So yeah, now once again, you know, it's all separating. So Oliver, the acid that I'm using is about 10% by weight hydrochloric acid. So it's 10% by weight hydrochloric acid, 90% by weight water. And the base that I'm using is about 20% by weight sodium hydroxide. Yeah. And then in the bottle, it's you know, a mixture of salt water, isopropyl alcohol, and universal indicator to get the color changes. Let's add some base. Here we go. Let's add some base. You got it, Oliver. Thanks for the question. I appreciate it. A couple drops there. You can see the blue color developing. Sometimes it's fun. I will do this. Sometimes it's fun to add the acid while the separation is still occurring. You can kind of see it here, right? You can see the alcohol layer. This is the emulsion layer. This is the saltwater layer. You can see that the base kind of settles in the emulsion. So I'm going to mix this up. It's easier to see with the acid. The effect is easier to see. So we're going to do this with the acid. All right, here we go. Mix this up. I think I added enough base to make this go basic. Let's see. Oh, yeah. We got a definite color shift to blue, man. That's deeply blue. So we're definitely at like a high pH, maybe 9. Let's watch this separate. And while the separation is happening, I'm going to start adding some acid. You'll be able to see the 3 layers quite easily when I do this. Remember, there's a saltwater layer. That's this magenta layer on the bottom. There's an alcohol layer. That's sort of the dark blue at the top. And in the middle, you can see like a faint purple. That's the mixture of the alcohol and salt water. It's transient. Yeah, this is live, Nathan. Okay, so I'm going to start adding some hydrochloric acid. Hey, you can see it. Come on, baby. You see it? Let me add a little more just so you can make sure you see it. So the acid is resting at the interface between the alcohol layer and the emulsion layer. You can see it just, you know, the acid's going to be red in color. Nice, Oliver. Is there such a thing as a nonpolar pH indicator? Everything you see is always water-based. You know, what's interesting there, Frog Z, is a lot of the indicators are nonpolar, and they dissolve better in nonpolar fluids. But we just use, you only need to use just a tiny amount of them to get the color, so they're not that hard to get it to dissolve in water with the, you know, with the very low amounts that go in there. Looks like a solar flare. I love that. Looks like a solar flare. See that? All right, let's mix it up. I'm going to put a glove on just because I'm spilling just a little bit on my hands. Forgive me for a second. I got to get a glove on. Oh, let's do it here. All right. It does look like fire. It looks like a negative as it develops. Yes, indeed. All right. Let's put the lid on. Shake this up. See what the pH ends up being. Well, that's a nice magenta. Look at that. I didn't add enough acid. Isn't that interesting? So it's still like all of the acid was neutralized by the base already present in the bottle. Isn't that interesting? There's a crap ton of base in there. Yeah. So that's why it remained blue, which is cool. So we got to add some more acid here, folks, to try to get a color change. Let's add a few more drops. All right, here we go. I'm going to wait till it separates just a bit. So once again, you can see the saltwater layer, that's magenta. You can see the deep blue alcohol layer, and then the mixture of the saltwater and the alcohol, we call that the emulsion. It's transient, and it's going to shrink. Shrinks over time. And when I add hydrochloric acid, which I'm going to do right now, it's the same acid that's found in your stomach. It's just this is a lot more concentrated. I'll add a few drops. The acid sinks below the alcohol layer, but it floats on top of the emulsion layer. So it sits at the interface between the alcohol and emulsion. You see that red line developing in there? Ha! Isn't that cool? Isn't that cool? So now there's 4 layers. We got the alcohol layer. We got the acid-rich alcohol layer. We have the emulsion, which you can see is it's shrinking over time because this is a mixture of the salt water down here and the alcohol up here. So, the alcohol goes this way from the emulsion. The salt water goes this way. It'd be very interesting if you could do this in a way that was spontaneous. I see it as art as the way it is. It's just like, the artist just has to be involved in the process continually. But yeah, it'd be interesting if somebody could figure out how to engineer what you suggest, Cy. That'd be really cool. Yeah, that's true there, Harsh. So what's going on there is I'm noticing that the hand that I put on top of the bottle, that tends to get wet because it's just a little bit leaky. But the rest of the bottle is very dry. I'm not noticing anything on this other hand. But thanks for your concern. I appreciate it. Now we're at green. We're at pH. We are at pH 7. And we can watch the separation going on here. It's interesting here. You can see the alcohol there looks a little more yellow. The saltwater layer is almost colorless. And now the emulsion's green. So we're seeing what's called a solvatochromatic effect, where the color of the indicator depends on the solvent that it's in. Up here, the solvent is in pure alcohol, and it has a different color than if it's dissolved in the, I don't want to say dissolved, but if it's located in the emulsion layer, which is a mixture of salt water and alcohol. Very nice, huh? I'm going to shake this up. See there? No, I did it. Yep, you were right. I should have gloved this hand. I put my hand up here. I got a little wet. I'm going to shake this up just a bit. See if you can get a nice, sharper separation. I'm going to get a glove on the other hand. This is for you, Harsh. Get another glove on the other hand. Should have listened to you. All right. The Venusian sunset. Interesting. Look at that. And now, interesting. It's no longer green on the top. I don't know what the heck's going on there, folks. Remember last time it was yellow. What the heck? Electro boom chemistry version. I don't know if that's true. I do try to stay fairly safe in my experiments. Even though I do try to, light things on fire, blow stuff up. I do that occasionally. Just always do it in the, with proper precautions around. Oh, gosh. All right. Let's add some acid to this. You can easily see the 3 layers now, right? There's salt water, there's the emulsion, there's the alcohol layer. We'll add a little bit of acid to this, which always seems to sink below the alcohol layer and comes to rest on top of the emulsion. We can watch that happen. I just added 2 drops. Look at it. You can see it. There it is, the red. That red layer. Looks like sunrise breaking through. Yeah. You can see just a real thin layer of the emulsion. That emulsion just always separates back into the salt water and the alcohol. Let's give this baby a shake. This should get us down to a lower pH. Let's see. Try to tighten this up a little bit so it doesn't leak quite as much. Here we go. Shake that up. I agree, Cy. There's so many experiments I need to do. So little time. So many experiments, so little time. You actually buy that T-shirt on my swag site. Cool, huh? Very beautiful. So Toast is saying they lost most of their fear around hydrochloric acid and sodium hydroxide. Well, it depends, right? Toast. I mean, it depends on their concentration. Like I mean, point 0.1 molar hydrochloric acid. Yeah, I don't worry about that much. I start getting north of 3 molar, and then I think about it. Make sure I get my gloves on. Yep. At least that's the way I view it. You may view it differently. I don't know. What about sodium potassium alloy? I've never used it. So I can't even talk about it because I don't know. Doesn't a pH indicator work because color changes due to some? Yes. So let's talk about Harsh. Let's talk about how pH indicators work. Thanks, there, Harsh. So we're going to talk about how pH indicators work. Sorry about that, Viva la France. Let me before I do this, let me go ahead and add some base so we can see a color change and a separation while I'm jabbering on about how pH indicators work, okay? So there's a few drops of base. We're going to give this a shake, see what happens. So here's the way this works. Here, there we go. Get that separating. So we're going to talk about just one particular acid-base indicator, and that acid-base indicator we're going to talk about is phenolphthalein. So phenolphthalein, I want you to look right here. Its pH 1, 2, 3, 4, 5, 6, 7. It's colorless all the way through there. And then when you hit pH 8 and above, then it starts to look pinkish, all right? So we're going to talk about this one because it's the simple case. So here's the way it works. Phenolphthalein, in the presence of acid, has a ring-shaped structure like this. And when it has this structure, it's colorless because its structure determines its properties. All right? Now, there's another thing that goes on at low pH. There's a lot of what we chemists call protons around. They're just H+ ions. And we're going to imagine this H+ ion is like this little white thingy that I have here. And what phenolphthalein does is it grabs onto that proton and it makes that ring-shaped structure. Now, at high pH, what happens is the protons are removed from solution. And so it's less likely that the phenolphthalein will be able to grab onto one. And so when the phenolphthalein in the high pH loses its proton, it no longer can keep this ring shape, and it goes like that. It pops open. And with that change in chemical structure comes a change in color. It goes from colorless to pink. And that's the basic idea behind how phenolphthalein and many of the other indicators work. So another question here. Consumer household grade isopropyl is at 70. So that's correct, Ken. The other 30% is water. If you salted isopropyl, it would theoretically purify the alcohol. That's correct. Ken, by the way, I happen to also buy 91% isopropyl alcohol at the store. But yeah, you could throw a bunch of salt in there, and you'd be able to get a lot of the purify the alcohol. I wonder how these experiments would look in monochromatic red. Well, let's find out here. I don't know. This is perfectly monochromatic. Let me see if we can get it. All right, there's red. Oh, no, it's changing. I don't know if I have. There's red. So this is just plain red light. That's what it looks like under red light. All right? So that's what it looks like under red light. Let's see what it looks like under, it's not this is LED light, okay? This is LED light. Now we're going to go to, come on, man. That's white. Curses. I got to figure out how to use this dadgum thing. I had it. There we go. That's red. That's like a violet. So this is probably a combination of blue and red. This is like an aqua, so a combination of blue and green LEDs. That's just yellow, so this is probably a combination of red and green LEDs. That's white, so it's red, blue, and green. That's our aqua. Come on, man, I want to go back to red. That's the whole rainbow flashing around. That's flashing. Okay, here's red. There's green. Dang it. Oh, shoot, I just had blue. That's green. Oh, I'm dimming. There we go. That's white. Give me a second. Green, blue, yellow, like an aqua, cyan. This is magenta, red, green, blue. A chemical party. So there you go, our different colors. It's kind of interesting. Thanks for the suggestion. Thank you for the suggestion. Back to white. Turn it off. Get the backlighting, because the backlighting looks nice, yeah? The backlighting makes it look pretty. All right, folks, I'm getting at the point in the live where I usually turn the camera around and talk to folks for a little bit. If that's not something you want to see, this is your warning. You're going to see a 57-year-old man in their basement. Again, if that's not something you want to see, might be a good time for you to, call it quits for the day. All right? Just letting you know. Does the chemical structure size change the absorption refraction rate? So yes, Herbie, so the chemical structure is going to determine how that substance absorbs light, for sure. So it can shift the wavelength at which the light gets absorbed. It's a side tuber. Hide your eyes. I know, right? Tell me about it. Here we go. Turn it around. I gave you a fair warning. All right, let's turn this around. Let's put a little lighting on so it doesn't look too bad. There we go. All right, folks. Hey, thanks, Ersai. I appreciate it. Thanks for joining in. I appreciate folks who hang out and watch my videos. My channel's been struggling a little lately. I think YouTube might have changed the algorithm, and man, I've really been having trouble lately. So yeah, how are folks doing out there? It was good hanging out with you all today. I'm not seeing a whole lot of questions coming through. I got a mess to clean up. Yeah, we had a good time today. Doing our normal experiments. We did some acid-base stuff. I'm hopefully in the coming weeks, I'll be able to get into my lab. And so for the live, we'll be able to do some experiments with maybe some liquid nitrogen. I did that on TikTok the other day. Yeah. I know, right, Frogsy? Put time and effort into something, you get 57 views, you make a stupid meme, and you get 1,000. I hear you, man. But yeah, I'll probably be doing some YouTube lives in the future where I hopefully will be able to get in the lab and do some, do some experiments with liquid nitrogen. I did some, like I said, yesterday on TikTok. It worked out okay. We did quite a few things. Had a good time. So thanks for joining in today. Herbie's kind of behind. Could I explain the different kinds of property changes in relation to structure? Sure. So, like phenolphthalein in an acid, phenolphthalein is going to have a ring-shaped structure because there's a lot of protons around. We're going to pretend this is a proton. We're going to pretend this is phenolphthalein. All right, this is cartoon version stuff, but it's just a way to at least begin talking about it. So when there's a lot of protons around, phenolphthalein, it grabs onto those protons and it makes a ring shape. And when phenolphthalein has this ring shape, it's colorless. It shows no color. So the structure of the molecule determines its properties. And in this case, if it's got a proton in an acid, lots of protons around, the phenolphthalein grabs onto that proton, it's ring shaped, and it's going to be colorless. Now I do need a whiteboard there, Toast. So in a base, these protons are removed. So the bases, they steal these protons, and phenolphthalein, when it's not bound to a proton, boop, it goes like that. It pops open. And with that change in structure from, ring shape to open comes a change in property. So it goes colorless, boop, to pink. It just changes the way it interacts with light. Hey, thanks there, Lord Dustin. Appreciate it. Maybe. Sunset views might make nice shorts. Maybe. Like a photophobics relationship. Maybe, Freebie. Yeah, I like it. I like it. That's kind of nice. Well, yeah. We did some experiments today, had a good time. This is usually time on the weekends, usually in the afternoon, or right around noon sometimes a little more towards the afternoon. I usually get on. We do some experiments. We talk a little bit about life. We do some, I like to call it science art, where we just look at, beautiful chemical reactions and just talk about them. We had a good time today. Thanks for hanging out, everybody. I enjoyed seeing you. Thanks for supporting the channel and allowing me to do my childhood dream, which is to do science experiments for people. You're helping this old man's dreams come true. So long, vive la France. You guys have a great day, and I will see you next week. So long, folks. Thanks, Herbie.